Hello, doctor. We are doing exhaust fan with three of our teammates, and my name is Danusraj, and my matrix number is 195827.
My name is Joanna binti Ilyas Rai. My matric number 197000.
My name is Roga Vadivelan and my metric number is 197352.
Okay, before we start to our exhaust fan, let me explain about our introduction. Okay, an exhaust fan is known as a ventilation device where it works by pulling out the polluted air which from the surrounding to a place where it replaces the clean air. Exhaust fan will eject the unclean indoor air to outside the environment and letting the clean air passing through the exhaust fan from the environment. These type of cases mostly harmful to people health when they are in working place. An exhaust fan consists of blade and motor which will make it to rotate efficiently. So these blades work by slicing the stationary air in the surrounding air and pushing them out of the room. So the amount of air enters and release is measured in the unit of cubic feet per minute, and it depends also on the revolution per minute for the efficiency to pass the air from outside and inside. For an example, these types of exhaust fan are used in kitchens and bathrooms. Furthermore, for an example, a kitchen without cooking need roughly 6 air changes per hour, which means the air from out to in to out to clean the place. So then a ventilation fan mostly using electric motors, engine and solar power, and also switches that we used in houses. Okay, the number of blade used in a fan may vary from 3 to 5 for it work with maximum efficiency. So for the next part, problem statement, I pass it to Loga.
Alright, for problem statement, here in this project we're going to find and to identify drag force and lift force. So here we're going to uh, see how which exhaust fan is going to be working efficiently by changing its design into three. So here we use two software to do that, which is Katia and NSYS. So for the third part, I will pass to Juliana.
Okay. Hi, doctor. So my name is Joanna. I will explain about modeling state. So for the modeling state, we designed the exhaust fan using Katia V5R21. So there are three exhaust fan with different angle of attack and with similar design shape. So here the diagram, the figure for the three design. So this one is the first design that made by Lee, and the second design is made by Danus, and the third design is by Loga. So for the design, we just do the design like change the pitch in that Katia. And this one, the pitch is 160. This one 200, and this one is 250. So after we finish the designing using Katia, we move on to NSYS using NSYS R19.2 to analysis the exhaust fan to find the drag and drag and lift force, because using NSYS we only can find the lift force. So downforce is the negative of lift force. So we just change the negative and positive signs. So the step for NSYS is first we gonna import we're gonna use project schematic fluid flow fluid. This one in diagram 3.2. So using this one, we input the design. We just right click geometry and we input the design into the geometry. And then after we input the design, we right click again and enter and click design modeler and enter design modeler. Then the window will open and here the part of the design modeler window. So for the first step, we construct the enclosure first. So this one enclosure, and then we input the enclosure details. We using shape. The shape we using is cylinder, and with radius 5 mm. And for the positive axis, we put 300 mm, and negative axis is 800 mm. So after that, we click generate this one, we generate, and then the figure will appear like this. So this is the enclosure, and then after that we create the boolean under create toolbar. After we create the boolean, we input the operation subtract, and the target body we click the cylinder, and then apply. Tool body we click the fan inside the enclosure, and then apply. So we click generate, and then for the ANSYS for geometry part done. So we just repeat this step for the second design and third design. So I'll pass to
Danus.
Danus to explain about meshing.
Okay, thank you, Zurana.
Okay.
Let me continue meshing. Okay, meshing basically is done after programming in modular geometry. Okay, basically what is meshing is we use it to control the accuracy and speed of the simulation. Basically, in the meshing, we change 4 elements. The first one is element order, which we change it to program control. And then we name all the surroundings, which means the enclosure just now. So first of all, we change the wall, which is the curve of the cylinder, and the front, which is near the fan. The circle, we name it as inlet, and the one far with the fan, we name it as outlet. Okay, basically, next we add quality, we change it the smoothing to medium, and others such as size, invitation, and advance will remain as default. So after all the modification have been done, we proceed with next stage, which is known as setup. Okay, these are the 2 figures, the process of making the meshing. Okay, then let me pass it to Loga for Fluent CFD.
The Fluent CFD is the third element, which is setup. Here we have done some steps. First step is we set up K omega. K omega. Oh, atas. Set up K omega from the viscous model. Then we put the constant for the velocity magnitude, which is 100. Then we compute the projected surface area and copy to the reference value. After that, we initialize it, and the variables were calculated, which were drag force, lift force, drag coefficient, and lift coefficient. Then these steps were repeated using design 2 and 3. Okay, that's all. The results part was done by Juliana.
So for the result, here the result. So this four we get from the setup setup step. So this one is the ratio, and this here the graph for the tree design. And then this one is the flow of the tree design. So so that's all for the result. I'll pass to Danus and Loga to explain the discussion.
Okay, for the discussion part, we use the design we built in Katya because we learn it when we are in SEM 1 and which is easy for us. Okay, basically what we did here was we make a cylinder, then we adjust the pitch for the blade positioning, and here are the measurement that we gave. And basically, other than that, what is different from three of our design basically was the shape and the blade pitch, the positioning of pitch 90-degree. So next, after we done our designing, we stimulate using ANSYS, which will be explained by Loga.
After we stimulate, we found that design 3 is the best fan chosen because it has higher angle of attack, thus it can remove more volume of air from a particular space to outside. And with lower drag force, it can work even efficiently. This is done in the discussions part. So the last part conclusion is done by Juliana, and she'll explain about it.
So in conclusion, the most design from the all three design is design 3 because the ratio value of this design is 5 to 5.2702. So this one I put the appendix distribution from our group. So I think that's all from our group. So thank you. Okay, bye.
Thank you,
Okay, thank you, Doctor.